Triangles. So of course a triangle is a shape with 3 sides and 3 angles. But we can have different types of triangles depending on their properties. We've got the equilateral triangle where everything is equal. All the sides are equal and all the angles are equal. Now don't forget these little lines here, they mean that these are equal. We have the right angled triangle where one of the angles is right angled, and we can see that by the box shape, which means it's 90 degrees. Isosceles, 2 of the sides are equal, and then the 2 opposite angles are also equal. So you can see how these are opposite each other. They're also equal to each other. Then we have scalene, where nothing is equal. No equal sides, no equal angles. Those are called the side names of the triangles. We can also name the triangles by their angles though. So we've got acute angled triangle. This is any triangle where all the angles are acute. Doesn't necessarily mean that they're all equilateral. It could be a triangle like this, where they're all acute angled. We call it an acute angled triangle. Next we have the right angled triangle, which is obviously a triangle with a right angle inside it. And we have an obtuse angle triangle where one of the angles is an obtuse angle. As I said before, we can have markings to show us that these are the same length. We can have markings in here as well, especially if it's double, to tell us that those are the same size. So any line that has the mark on it means they are equal in length, and any angle that has the mark on it means it's equal in size. We can be asked to name these triangles more specifically. So in this first example, I have an equilateral triangle, but they're all acute. So I can call it acute angled equilateral. In this one, I have an obtuse angle. So it's an obtuse angled, and then these two are the same size. So that tells me that it's an isosceles triangle. So it's an obtuse angled isosceles triangle. Now in this one I see my right angle, so I'm calling it right angled. And all 3 are different, so it must be a scalene. So I hope you can see how we can use the names to be more specific about the triangles. Next, what we need to know is the angle sum of a triangle. Now, triangles always add up to 180 degrees. I hope you've had the opportunity to prove it in class. If not, you can come chat to your teacher about how can you prove that triangles always add up to 180, but you just now need to know that. And then we can use it. So this says, find the size of the angle that is labelled. So that's the angle C. I like to always do a symbol so my teacher knows that I know the rule. So I'm going to do a triangle with 180 in it. What I first need to do is figure out how much have I used up. So I'm going to do 70 plus 30. And that's 100. So I've used up 100 degrees. My total is 180. My total is 180 and I've used up 100, so I'm going to take away 100, which means I've got 80 left. So that tells me that C equals 80 degrees. Make sure we got that degrees sign. Let's try one more. So again, I'm going to tell my teacher I know that it's 180 in triangle. Now I have to figure out how much have I used up. So in this angle I've used up 90, and in this angle I've used up 16. So I'm going to add them together. So I've used up 106. I have 180 in total, and I'm taking away 106, and that's going to leave me with 74 degrees left. So that means that C must equal 74 degrees. Lastly, sometimes we might have to use our triangle knowledge to answer the question. So again, a triangle has 180. I had 180 and I've used up 22. So take 22, which leaves me with 158 left. Now I know for an isosceles triangle that these must be isosceles because they're both equal. And I know that the angles that are opposite these are the same size. So C and this other one must be the same size. So I have to split 158 degrees between these two. So I'm going to do 158 divided by 2. And I'm going to say that's 79 degrees. 158 divided by 2 equals 79. So C must equal 79 degrees. So sometimes we need to use our triangle knowledge to answer the question. The last thing we need to know about is the angle, the exterior angle. So we call this the exterior angle because it's on the outside, exterior. Now because we know that an angle always equals 180, which is a flat line, if we cut off A and put it here, and we cut off C and put it here, we would find that A and C is the same as D. And you could do that with a piece of paper if you wanted to. But basically, you just need to know the rule is that the other two angles added together equal the same as the exterior angle. So if I want to find this here, I'm gonna draw a symbol like this for my teacher. And these two angles added together will equal this one. So I've got, oh, sorry about that. 70 plus 60 equals 130. So X must equal 130 degrees. That's how simple it is. Sometimes, however, we will be given the outside number. So what we can do there, symbol again, is this is the total. And this is how much we've used up on one angle. So take 45, 95 left. So this must equal 95. A equals 95 degrees. So, a couple things to recap. Make sure you know your names of your different triangles. Remember that the sum of an angle is 180 degrees. And if we want to find the exterior angle, it's the other two angles added up together. I hope that helps you when you're working with triangles. Here's a picture of my puppies when they first came to live with us, and Waffles thought that she could walk herself on her lead. She loved to walk herself on her lead everywhere she went.